Hi, I'm doing a test, a few questions on numbers and operations, plus as measures. So this can be used by the grade 11s and the grade 10s who are doing the ordinary level syllabus. So I think we can just get right to it. The first question obviously is some numbers that are given in standard form or also known as scientific notation. So you can actually go ahead and use your calculator for this because you are allowed to use a calculator. So you can have 3.1, and I'm going to use this one here, times 10 raised to the power of negative 3. And we're going to subtract that, negative 3. We're going to subtract that from 3.1 times 10 raised to the power of, is it negative 4? So that's obviously because it's negative 4 power, that's a smaller number. And then you get that answer as a decimal, but the calculator is set in such a way you can, if you want to, um, you go to your setup, shift setup, and then you go ahead and you choose 7, which is scientific notation. So if I hit 7, it's going to ask me what is my rounding that I wish to apply. So I want 3 significant figures, and it's going to give my answer as 2.79 times 10 raised to the power of negative 3. Okay, so essentially you have many ways you can do this. You can write them as ordinary numbers, and from there you can then go ahead and then you do your so to say, you didn't write it in standard form. Okay, should not be spending too much time on that question. A total of 950 students entered the course competition in 2021. They are saying that that was an increase of 25%. An increase of a certain percentage means that whatever it was, add a 25% increase, which is 125%. So that 10950 represents 125% is equal to 950 over something. Now this something is very important because if it's an increase in 2021, then it means that the entrance for 2019 must be far less than. That is why your fraction is therefore essentially improper. In fact, this is actually like a reverse percentage scenario, but I did the equivalent fractions for you to understand where it comes from. So if we were to cross multiply, so we're going to have 125x here, and that's going to be 100 times 950. And then I'm going to get rid of that 125, so to speak, in front of that 100 and that x. That is going to give me that x equals to 100 over 125. Can you see where the reverse percentage scenario comes into play? So when you do that, you expect to have an answer that is far less than your original answer because that was an increase of some sort there. Okay, so 760 is going to be the correct answer. All right, question 3. This question deals with lower bound and everything is measured correct to 1 decimal places. So if you have 1 decimal place, which is the same as 0.1 or 1 over 10, if you go ahead and you divide that answer by 2, you should get 0.05, which is what you're going to be subtracting from both numbers since you are looking for the lower bound. And if you do the subtraction from here, you say 4.0 minus 0.05, of course that gives you 3.95. And because it's multiplication, and when you are looking for the lower bound in multiplication, you simply will be multiplying the lower bounds together. So 2.7 take away 0.05, that's going to give you 2.65. So you're just going to go ahead then and say the volume lower bound will be the lower bounds multiplied by each other. Okay, and what is important is you should not round this answer. So if I write this as decimal, I have to write out everything, 10.4675. All right, otherwise you can also go ahead and you can write the answer as a fraction or as a mixed number, but the moment you write it as a decimal, you are supposed to write down the full calculate display. You may not round questions on limits of accuracy. Right, question 4 deals with proportion. So they are saying here that y is inversely proportional to x. Essentially, y should equal to some constant of variation upon x. So we are now going to substitute the values that we have. So when y is equal to 8, then x is equal to 9. So in order for me to find the value of k, I will be multiplying these two together. So this brings me to my equation now. My equation now is y equals to 72 upon x. Now if I have the equation with my constant calculated, I can now calculate or work out whatever it is they want me to find. They say find y, so they give me the value of x. So find y when x is equal to 6. So let's just input that and see what is it that we are going to get as our answer for y. Of course, our answer for y in this particular case is going to be 12. And that is the solution there. Step by step, find the constant of variation, then you substitute in the values, and then you find the missing one after they gave you one. Now, there's many ways you can do this question. You essentially have to change kilometers into meters, so you need to know that 1 kilometer is exactly equal to 1,000 meters. And you should know that 1 hour is equal to, there are 60 seconds and 60 minutes, so is equal to 3,600 seconds. So I have got 108 here, so it will be 108 times 1,000. That's going to take it to meters. That should be divided by an hour, but the hour should be now written in seconds, and we know that 1 hour has got 3,600 seconds. Okay, just for you to know, this means the same as meters divided by seconds. That's what I have over there. All right, so you can just go ahead and grab the calculator by sort of dividing 108,000 by 3,600. So it's 108,000 divided by 3,600, which should give you 30. Okay, let me just go ahead and write my, change my calculator back to normal mode. So the answer is 30. Okay, so I'm just going to write 30 here. What is interesting, if you have a calculator like this, is that I can actually use my calculator to do the conversion. So for that, I will be taking shift and I'll press conversion here where the 8 is. And I'm going to hit 20, let's say 2020. And if I do that, okay, this one is going to convert meters per second to kilometers per hour. So let's say shift convert. These things are typically at the back of your calculator if you have such a calculator. So it must be then 19 just to convert. Let's say we take 19. Okay, there we go. So what it does is it's going to change kilometers per hour to meters per second. So I'm just going to go ahead and put 108 here. And the calculator is going to do the conversion by its own. Can you see that it gives me the answer of 30? Now, of course, this calculator is not allowed perhaps in your examinations because it's programmable. But I just want to show you that supposedly the conversions can be done also if you have this type of technology or calculators. All right, let's go to question 6 again. You have got the individual tax income structure of Namibia. Now, obviously, these things they change year in, year out, or periodically. But this is the rates from the years of assessment that is on the end 2025, 2026. These things are available. Now, what we have here is we have that a certain Mr. Gordon, he earns 300,000 Namibian dollars per year. And then there are things that should be reduced or deducted for tax purposes. So they shouldn't essentially be taxed. So that taxable amount means that you are supposed to say, wait a minute, before I even consider going to the tax rate and see where he falls, I need to remove the stuff that should not be taxed at all as it is. Now, finding the difference there, you're going to have a difference of, let's just have this here, of 248,000. So that's going to give you 248,000. Okay, but that's not all. So that is one mark. Now they want tax income, the amount of income that he must pay. So before I do that, I'm going to calculate what is known as the taxable amount, okay, or the taxable income. So maybe I should call it, let's say, the taxable income, because not all of this will be taxed. So I have to take that 248,000. Now I must go to my table to see. The table will always be provided, or a part of it. You don't have to study the table, okay. If you have to look at which tax bracket does the person falls, obviously not the first tax bracket, not the second, but if you look closely at the third one, this one here that I'm pointing with the arrow, essentially I can also highlight it. He is earning more than 150,000 but less than 300,000. So this is the tax that he has to pay. So what is important for me before I start with the formula is this last amount. And that's what you're always going to do. After you deduct taxable deductibles, then you have to use that last amount by subtracting it from the 248,000. So this last amount of 150K or 350K, these ones that are appearing last on the tax tables will always be the ones that you're going to subtract after you did the first subtraction as it is. Now, if you do that, you're going to get $98,000. So this is the money that you are going to input using this formula here. So you're going to say the tax that he has to pay must be 9,000 plus 25% of that 98,000. So the tax for the year that he has to pay will be 9,000. Of course, you get this from the tax table times 25% of that 98,000. You do not find 28 or 25% of the whole 248K. Okay, so that is what that formula is. Everybody has to pay that if you fall in that bracket. So you can just go ahead and use your calculator, and that should give you your answer, right? Without having to write down things step by step. The calculator can do all these calculations, especially if it is a scientific calculator, right? So I'm just going to type it in as the display is indicating here, and this is going to take me directly to the text, which should be in the 30,000 range. So $33,500 is what this person is going to pay for tax for the year. So it's $33,500. Suppose they ask you to pay as you earn, how much actually does he pay per month? You're just going to take that 33,500 and divide it by 12. Right, question 7. Mary wanted to buy a sewing machine, so I put a picture of a sewing machine for you so that you can know what it is. Okay, that's the only reason I put that picture there. She can buy it for 3,150 cash, but then if she wants to hire it or buy it on hire purchase, she has to put down a 250 sort of deposit, a down payment, and then she needs to pay 12 monthly installments of $280. This is what she is paying on HP, hire purchase. But the question asking, how much more will Mary pay? So she will pay, if you take that HP amount and you subtract the cash from it, okay, subtracting that cash will give you exactly how much more the person has to pay. So just for interesting purposes, let's just see how much the person is going to pay on everything. The 250 is a down payment, so it's also part of the payment essentially towards the sewing machine. So 250 times or plus, then you take the 12-month installment multiplied by how much the person is supposed to pay every month. So can you see that it ends up that he pays 3,160 or 610 rather, if he was to pay this over that period of time. Now, finding the difference there will tell you how much more the person has to pay. So minus 3,150. So that gives you 460, which is what the person will be paying more if he was to take the option of buying the sewing machine on hire purchase. Right, we come to question 8 now. There are many ways you can do question 8. So first of all, a train journey starts at 17 minutes to 10 in the evening, and then it takes 8 hours and 32 minutes. right? So what you know, essentially, common sense should tell you that if something starts to 10 at night and it's 8 hours, so it's going to be somewhere the next day in the morning. That's what you should be expecting. There are many ways. You can ask yourself a bunch of questions. How many um, minutes is this to midnight? Okay, for you to say, okay, wait a minute. If I have midnight, which is this, and I am saying, let me take the time from midnight. Okay, now you can do this many ways. Obviously, you cannot subtract 43 minutes from no minutes. So you go and borrow an hour. So if I borrow an hour here, I'll be essentially left with 23 and 60. So the new thing becomes 2360 minus 2143. Okay, so now it's possible to subtract um, 43 minutes rather from 60. So that should be 17. So it is 17 minutes, and if you subtract 23 minus 21, so that's 2 hours and 17 minutes. So why is that significant for me? I will be saying, okay, so from midnight or from that to 10 to midnight, it's exactly 2 hours and 17 minutes. So what time would it be then in the morning? It's going to be take away the 8 hours and 32 and take away the 2 hours and 17 minutes from it. And if you do so, you'll end up with 06:15, which is the time that I expect this journey to finish. Okay. Another way that you can do this, of course, there are many ways that you can do this. You can use your calculator, and I will be doing it right here so that you can see. So I will be taking 21, and I'm using this pattern here for hours and minutes and seconds. 21 hours, 43 minutes. If I add 8 hours and 40 and 32 minutes, I'm going to add 30 hours and some odd, right? Now, it's a lot, but now I have crossed over to another day, so I'm going to have to take away the 24 hours from there. And the moment I do that, I have got my time here, which is 6 hours, 15 minutes, but then we're asking what time, so you're going to write it as 6 dot 15 or 15, and then you can say AM, okay, the digital, the 24-hour clock, that's how we write it. So, or you can say 6 dot, and here you must now indicate AM. Right. Question 9. So I have a table over here that it's going to help you to convert between volume and capacity. So just to explain a bit, on this side, if you were going from cubic meters is bigger than cubic decimeters, which is bigger than cubic centimeters, which is obviously bigger than cubic millimeters. But if you were to go from here, cubic meters to cubic decimeters, then you are going to multiply by 1,000. I'm just going to write 10 raised to the power of 3. The same applies if you go from cubic decimeters to cubic centimeters. You'll be multiplying again by 1,000, okay, or 10 raised to the power of 3. Also, essentially, if you go from cubic centimeters to cubic millimeter, you're also going to multiply again by 1,000. So in this volume, you work with thousands. If you have to go the other way around, so let's say you go back from cubic millimeters to cubic centimeters, a smaller unit essentially to a bigger one, you will be dividing, and you divide again by 1,000. And so will it be for each sort of um, movement that you are making along there. So you'll be dividing as you go from small to big by 1,000. So if I was to change cubic meters to cubic centimeters, I'll be multiplying it by 10 raised to the power of 3 times 10 raised to the power of 3, which is like a million. Right, that takes care of the volume side. Let's come to the side for the capacity. Now, here is where I need to explain a bit of something. At this part where I have these two, it means that these two are exactly equal. And here also is equal. That means if I have 5 cubic decimeters, it's exactly the equivalent of 1 liter. That's what you need to understand there. Or if I'm here and I have 1,000 cubic centimeters as volume, is exactly the same as 1,000 milliliter. That's what that means. That's why I had them drawn like that. Now, if you move in the capacity part, so you go from liters to deciliters, you multiply obviously by 10. Going from deciliters to centiliters, you multiply by 10. And from centiliters to millimeters, you multiply by 10. So if you want to change 5 liters to centiliters, for example, you'll be saying liters, you're going to multiply by 10, and I multiply again by 10. So the answer would be like 500 centiliters. I hope you understand that. So multiply by 10 times 10. Now, also, if you are going backwards and you go from milliliter to centiliter, you're going to divide, but you divide essentially by 10. So you divide by 10 and so on. Okay. Right. Here's the thing. If I have to move from cubic meters here, and I have to move all the way to centiliters here. So first I have to come where they are equal. Can you see what I mean? So I'm going to say, okay, to go from cubic meters to where the capacities are equal, I'm going to multiply by 1,000. So I'm going to say 8 times 1,000. So where that brings me, it brings me to 8,000, but that is now cubic decimeters, which is also equal to 8,000 liters. Now, if I'm at liters and I need to go to centiliters, I must multiply by 10 times 10, which means I must now multiply by 100. And that is going to give me 800,000 centiliters. Okay, so it's when you are moving from between the different units, so from volume to capacity, you have to find where they sort of are equal, and then you do the change from there. Okay, so they are equal at these two instances, and that is why you should remember that. Okay, let's do it the other way around. So I'm here at cubic millimeters over here, and I need to go all the way from cubic millimeters. So let me just highlight it. I'm here, and I need to go to deciliters. So for me to do that, I must come to where they are equal, which means I'm going to come here by dividing my answer by 1,000. Okay, so let's do that. Let's say, okay, taking this 650,000 and I divide it by 1,000 gives me 650. And it's bringing me to what? To cubic centimeters, because I'm now here. That is essentially equal to 650 milliliter. That's what it means there. Can you see that? Now I'm going to go from milliliter to deciliter, but I must divide. I'm not dividing by 10, but I'm dividing by 100. That is 10 by another 10. So from 10 times 10, so I must divide by 100. So I'm going to have to divide this answer by 100, which essentially will give me 6.5 deciliters. And that's how you do it. Of course, so you can write that table down and importantly so, play around with some of the measurements, and then you'll be able to do the conversion. Right, let's look at there's a last question, and I expect you to know another important fact is that 1 hectares is equivalent to 10,000 square meters. So 5 kilometers is the same as 5,000 meters. So therefore, using that fact of length, what does 5 square kilometer mean? It means 5,000 or times another 1,000. So it actually means, so let me just write it down here using a unit. 1 square kilometer is the same as 1 kilometer multiplied by another kilometer. Now you should know that kilometer times kilometer, well, of course, that gives you, if you change it to meters, that is the same as 1,000 meters times 1,000 meters, which is a number with 6 zeros. And that is going to be 1,000 square meters. So this is going to become 5 million square meters. Now, if I have to change it to hectares, I will now take that and I will use this fact over here, and I'm going to divide this 500 or 5 million by 10,000 in order for me to give my answer in hectares. So when you divide this by 10,000 square meters, all right, you're going to get 500 hectares. And this is area, okay? So this answer is 500 hectares. Right, it's a small, very short test of 25 marks. And hopefully you have learned a bit, a few things there and did some revision. Okay, the beauty is you can always pause the video and attempt to do these questions on your own as you prepare for your academics this year. All right.